The lightest rocks which the young Earth contained, made mostly of oxygen combined with silicon and magnesium atoms, floated above the outer core to form the mantle. We saw that convection currents were churning around in the outer core because of the heat from the inner core. These convection currents carried heat up through the outer core, which then heated the mantle. So more convection currents were formed there. These had important consequences on the outermost layers of the Earth, both on the young Earth and throughout the rest of history. On the young Earth, the convection currents in the mantle allowed the lightest rocks to rise up through the mantle and emerge onto the surface to form giant volcanoes. These were far bigger than any volcanoes we see on Earth today. The only comparable one we know is Mount Olympus on Mars, which is 3 times as high as Mount Everest and covers an area the size of France. And the early volcanoes on Earth were probably much larger. These early volcanoes released gases. These gases, such as carbon dioxide, had originally been dissolved within the rock. But as the rock reached the surface, the pressure which held the gas inside was released. This is similar to the bubbles in a bottle of Coke, which can only fizz up to the surface when you open the bottle. These gases gathered around the Earth and formed the first atmosphere. And this atmosphere had important consequences, one of which would lead to the eventual destruction of the volcanoes which formed them.